Hi, I am Tiffany Dixon, and I am presenting my project over Rene Descartes for MA570, History of Mathematics. Rene Descartes was born in France. He was born in a town in France in 1596. That town has now been renamed to Descartes in honor of him. Uh, his mother died when he was very young, and his father sent him to live with his maternal grandmother, but wanted him to be educated. So when he was 8, he went to boarding school, and then at age 22, he graduated with his law degree, even though he never actually practiced law. He did serve in the military and actually served in more than one military before becoming interested in philosophy and mathematics. So while he was in the military, he had some dreams or visions that he says led him to this path of philosophy. In 1619, he said he had 3 distinct dreams or visions that changed his life and led him to his philosophy. He sought to uncover the meaning of the natural world with a rational approach through science and mathematics. And his idea was to build a philosophy around something concrete, such as mathematics. And for people that aren't philosophers or mathematicians, probably his most famous quote is, "I think, therefore I am." And you can see in this photo, it looks like a very young Descartes. It says the full quote is, "I doubt, therefore I think, therefore I am." And he used that even as he started talking about the existence of God in his philosophy, and to prove the existence of a God. So some people say that he was the father of philosophy and was definitely more of a philosopher than a mathematician. That he just used math, algebra, and geometry specifically to explain this universal science, meaning explain the way the universe works, not just math and science. The quote I really liked from him says, "Arithmetic and geometry alone are free from any taint of falsity and uncertainty," meaning that if he could prove things with math and science where everything was certain, then he could take that and elaborate on that to the universal science. Um, Although it seems that maybe he didn't want to be considered a mathematician, he has made many contributions to mathematics that helped other mathematicians that came after him, and also his notations and the way we write math are still used today. One of his philosophies was that he determined to hold nothing true until he had established grounds for believing it true, which kind of made him like disregard all the other philosophy work before him. Unfortunately, that also made him not appreciate the achievements of other people because he felt like they hadn't proved their reasoning for the things that they discovered. Descartes had many books. The first one that I found that he had out was Direction of the Mind in 1628. And then the big one for math was 1637. The full name of it was Discourse on the Method of Rightly Conducting the Reason and Seeking Truth in the Sciences. But it had 4 parts. And so it had a part on geometry, optics, and meteors, as well as that discourse on the method. And then he had 2 other books on philosophy, 1641 and 1644. But the geometry part, the law geometrie, excuse my terrible French accent, which was part of that discourse on the method, is where we get most of the math that we credit to Descartes. I did find a picture of this law geometry on online on a site talking about selling it. Through a private sale for like 30,000 euros if you're interested. So looking at his work in math, he's credited with the notation we use today, not only the fact that we use X, Y, and Z at the end of the alphabet for our variables, for our unknown values, but also that we use A, B, and C for the known values. We use the exponents, the way we write x squared and x cubed is credited to Descartes. He was one of the first ones to use that notation that we currently use. Also, he was the first to discuss the logarithmic spiral, which other mathematicians talked more about. He also discovered the relationship between the vertices, faces, and edges in polyhedra. That formula is known as Euler's formula. he he spent more time on it after Descartes did, so Descartes doesn't get any credit on that one. Also, he found two more amicable numbers, which are two integers when the sum of all their possible divisors are each other. So when you take all their divisors and add them up, they add up to the other number. There was thought to only be one, and then in one pair, and then in 1636, Fermat found another pair, and then in 1638, Descartes discovered these two giant numbers were amicable numbers. He also was one of the first to propose setting equations equal to zero, the way we see polynomials today. Which helped get the quadratic formula, which had been around forever, to the way that we see it today, and using the notation that we use today. And also, there's a thing that we call in my classes, we teach Descartes' rule of signs, which means although Descartes did not necessarily acknowledge that there were negative numbers, he was aware that when you solved an equation, that you could get what he called false numbers, and that numbers under a square root that were negative, he called imaginary numbers. And I did read that he had the proof or the idea of the fundamental theorem of algebra in his work as well. So for most mathematicians, though, they give credit to Descartes for the father of analytic geometry. Like, that was his biggest contribution to math, meaning that he was the first to connect algebra and geometry. He classified curves or geometry and put them with equations, which had not been done before. Also, he had a coordinate plane, and we kind of credit him with our Cartesian coordinate plane, even though what he used in his work is not what we use today, but a general idea. And also, Fermat used did a lot of work with analytic geometry, but none of his work was published until after he died, and so Descartes usually gets the credit for analytic geometry. A little bit more about that geometry text. I read in one of my sources that it was one of the most influential scientific texts of the 17th century. And then our textbook says it did not have an immediate impact on the mathematics of its time. So it was interesting that those kind of are conflicting, but it didn't have an immediate impact because of a couple reasons. One is that he left out most of his proofs because he wanted to leave that to the reader to prove them themselves. But also the biggest reason is because he wrote all of his books in French, and at the time, Latin was the language that everyone published stuff in. So, Frans van Schooten translated this text into Latin and added his own commentary, including some of the proofs that Descartes left out, and then that let his work be dispersed among lots of different people, including Isaac Newton, who was able to read it once it was translated into Latin. And just kind of really cool to think about that this was published in 1637, and most students should be able to read it without stumbling on a bunch of notations that we no longer use. So that was really cool that it was one of the first texts that we could look at today and actually understand what it was saying. So the end of his life, he did never get married, but he did have a daughter with a maid who he lived with, but unfortunately she passed away at the age of 5. He moved to Sweden to work with Queen Christina with philosophy. I think he was supposed to be her philosophy tutor or guide, but he died very shortly after that in 1650 due to pneumonia. So was Descartes a philosopher or a mathematician? Descartes' always been one of my favorite mathematicians, and I was really surprised to read about all of his work in philosophy. And it made me feel like that maybe math was secondary for him. He used math to prove the philosophy. So although maybe his goal wasn't to be a mathematician, his goal was to talk about the connection between the mind and the soul and to prove the existence of God. He used math to get there, and his math was really important. So whether his goal was to be a mathematician, I think he became a mathematician, and a really important mathematician for all the work that he brought us. So these are my references. The project that I picked talked about what's a reliable reference and what's not a reliable reference. It was interesting to read some of the differing opinions and how some Articles have a lot more gossip stuff about Rene Descartes as opposed to like the Dictionary of Science Biography. That was very straightforward. Not many stories of legend about Descartes on those. But of these sources that I found, these all pretty much said the same things about Rene Descartes. And like I said, he's always been one of my favorite mathematicians, and it's been really fun to dig in and find out about his work, not only in math, but also philosophy. Thank you.